Welcome back, everyone, to Lecture 12 about evaluating expressions. And when we say they're evaluating expressions, we're just talking about you have some kind of algebraic expression, and it includes numbers and variables, and then you have some number that the variables are set equal to, and you just plug them in and go through. So there's not really too much, I guess, like background I have to go through with this, because all you have to do is just plug in the numbers and go with it from there. So in this expression, we have m, n, u, and v. And we also have an m equals 3, n equals -2, u equals 9, v equals -3. So all we have to do here is plug in these numbers and use order of operations to evaluate what that expression is. So here we have 9m, since m equals 3, 9 times 3, plus 7 times n, which is -2. In one set of parentheses, I just put brackets so I could use parentheses without it being too confusing. And then move this over just a smidge. Plus 6 times u, which is 9. Plus, oops, sorry, that's not a plus. That is, in fact, a minus, and I am a fool. Minus 8 times v, which is -3. Okay, so now we just evaluate this expression and this expression and add them together. So we have 9 times 3, which is 27, 7 plus 7 times 2, which is -14. So we have, oh, goodness gracious, 27 minus 14 plus 6 times 9 is 54. -8 times -3 is +24. So we have here 13 plus 78, which is 91. So overall, this expression is equal to 91. Pretty simple. You just plug and chug. If you've heard that expression before, just plug and chug. All you have to do is plug in all the things and just solve from there using proper order of operations, using the stuff you've learned before, essentially. Okay, so in this one, we have a, x, b, and y, x, y, a, b, all here. Okay, so we have 15 and then in parentheses a plus x, so that would be 6 plus 4 minus 15. And then we have b plus y, which is -15 plus -9. Okay, so we have here then is 15 times 10 minus 15, and then -5 plus -9, or -5 minus 9 is -14. One thing we can do to make this a little easier, since we have a negative here and a negative here, we can cancel them. We could like factor it out and cancel. So then we have 15 times 10 plus 15 times 14. One thing that's easier, that could be easier than, I guess, like separating this out, is notice that you have 15 and 15 times two different things. So you can do the reverse of the distributive property and do 15 times 10 plus 14, which is equal to 15 times 24, which is equal to 360. Alternatively, the only thing you can do differently is, aside from this this step right here where I did like from here to here where I did like the reverse distributive property, you could evaluate these expressions separately and do 15 times 10, which is 150, and then 15 times 14, which is 210, and then add those together separately to get 360. You'd get the same answer either way. I just figured that might be a little bit easier because it's less stuff you have to like plug in and evaluate separately. But you know, do what's best for you. There's always, almost like I said, almost always going to be multiple ways to do things. Okay. So then now we have 1/3 times p minus 6z quantity minus q. So now we have p, z, and q, and then we have p, z, and q as numbers. We have those expressions. So we're going to have, I'm going to write brackets again just because we're going to be plugging in multiplication, and I don't want it to get too confusing with too many parentheses. So we have 1/3 times 36 minus 6 times 3 minus -4. Okay, so 1/3 times 36 is the same as essentially saying 36 over 3, or 36 divided by 3. So that's going to be 12. And then 6 times 3 is 18, but we have to keep that subtraction sign attached to it. So we have 12 minus 18, and then minus the -4 is the same as plus a +4. So now all that we have left is 12 minus 8, which is -6, plus +4, so we have -2 as our final answer for that. Okay, not too bad. Moving along. Now, the last one is combines essentially what we did last time, where we're going to evaluate an expression that we're getting out of a sentence. It says, Eric placed an order for 9 baskets that cost $D each. Oh, that was not a change of color. And 6 trash bags that cost capital D each. So we have to write an expression for the total cost of baskets and trash bags. Okay, so what we can say here is that let C equal total cost in dollars. So we have C is the total cost, because we're assuming that we're buying both. So when they say the total cost here of baskets and trash bags, we're assuming that we're going to be adding the cost of each together. So to calculate the cost of that, we know that we have 9 baskets times D per basket, because that's what it said. Each costs $D, and we're buying 9 of them. So that's how you'd represent that 9 times 9 trash bags times however much each trash bag costs. And then we're adding to that 6 trash bags times D, the total, or like the cost per trash bag. So that's how you get the total cost. You have 9 baskets times $D per basket, and then 6 trash bags times capital D per trash bag. So you'd end up with the total cost in dollars. And that really is all there is to it for this one. Thank you for listening, and I will talk to you next time. Thank you.